Okay, so we're recording. All right, so what are we doing in this in this moment? We are recording with screen sharing. Yes. Okay, so what we're doing is I'm going to show you how in Excel to do a performance curve. Okay? So pay attention because you can look at this video later if you need to review. All right? So remember that Excel can do all of our math for us, but the way that you make sure it's accurate is it's got to be you need to tell Excel what to do the right way. Yeah? So here's what we're going to do. We have our leaf lengths here, yes? We have our interior, we have our exterior, right? Already labeled. Look at that. We're awesome. Okay. Then we're going to take our, basically we're going to do a performance curve for both the interior and the exterior. So we're going to do the interior first. So what did I say a performance curve even was? What did we say it was earlier? It's a cumulative mean, right? So it'd be good if I could spell though. That would help. So Excel does not use the word mean because they're lame, right? So they use the word average. So what we're doing here is we're using a tool where we're essentially, they call it function. That's what the FX is about. So we're inserting a function. And so we're basically telling the software, okay, I want you to do something for me. Okay. And so equals average is how you calculate a mean. And then you open up parentheses to tell it what you're calculating an average for. And so it's going to do a range of cells. Now, the first thing we're doing is we want to do a range. We want to do an average of just the first number, which is that same number, which I know is lame, but there it is. But I'm going to put it in here as if I was doing the whole equation. Okay. So what does this equation mean up here? Right? What it's saying is I am asking Excel to calculate the average of cell BC to cell BC. I'm seeing C, I mean 3. B3 to B3, right? That's what I'm asking it to do. And then as soon as I hit enter, it will do that. And fortunately, it matches, so that's good. Okay? All right, now, in order to get Excel to do this in all of those cells all the way down, we have to make one quick tweak to that. And then we basically just drag it, just click on it and drag it. Okay. So here's the tweak. Whenever you want a cell to stay like frozen on, this is always going to be your starting cell. What you do is you put a number sign in front of that. So see how I put a number sign in front of the B and the 3? That means that no matter what, we're starting with that cell. But then the ending is going to vary. Okay. All right. So here's how we do. Here's how we do. Right. So, okay. Still the same. Cool. Right. So let's see if this works. You ready? I'm always excited about this. So I'm going to click on my little green square. I'm going to drag it. I'm going to drag it all the way down. And essentially what I'm doing is I'm copying that. It's magic. Right. And so what I essentially did was I just copied that same equation all the way down. Okay, so now what am I doing? Now you always want to check and make sure that you entered it right because Excel just tells you what you ask it to do. And if you made a mistake by telling it the wrong thing, that's on you. Okay, so I'm going to just kind of spot check. So this one is going from B3 to B4. Is that what I wanted it to do? Yes. This one is going from B3 to B12. So all of these, is that what I wanted it to do? Yes. Hey, look at that. So it probably worked all the way down. Let's check. Right? This one is doing B3 to B33. Perfect. It's magic. Okay, it gets even better. You ready? You ready for the next thing? This is super exciting. You ready? Now, okay, I don't want exterior to be B3 and B1, right? I want this to be C instead of B, but I still want it to do the same thing. right? So I just copied it, changed it to C, and we still want it to start at C3 and then end it wherever it's ending. So do you see how I just copied that? And now grab my little square. Okay. Now, yeah, let's check just for shiggles here. Yep, looks good. Okay, we did it right. They're all C's, not B's, $sign. Yeah. Okay. So then what did I build in here for you to make your life easier? I already made a graph or line graph. And what I did to make this line graph, right? Let's just kind of walk through that so that you know. What I did was I went up to insert. In fact, here's what I'm going to do. I'm going to make another one that's identical to this just to show you how easy it is, right? So you go insert and then you want a chart and it's going to recommend a chart. You don't want a recommended chart. You're an independent person. You're going to do your own thing. And what you want is you want a line, right? Because we're looking at a trend. We want to see the cumulative mean leveling off. So we do a line. So we pick just a plain line. Don't do any of this fancy crap just to make it look cool. The important thing is that it's easy to read, not that it looks cool. Okay, so 2D line, beautiful. Okay, and then, oh, you know what? My ding dong self forgot to highlight my data before I did that. So you highlight your data. You highlight your data. Okay, so I'm going to go ahead and including with the labels. Yeah, so see my labels there? So I highlighted my data. So now I'm going to insert a line graph. Okay, this is the one that I made a second ago that I forgot to highlight my data first. Okay, and so see how I have manipulated this so that it has a title and it has the axes are labeled and all of that, right? So you would do that on your own. I already did it for you because I'm a nice person, right? But that part's not hard to do, right? That part you just basically it's hard in the sense that you got to figure out how to make Excel bend to your whim, but basically you put in whatever title you want, right? And then if you want to add something, you click the little add. If you're like, I need axes titles. Yes, you do, because this is a graph and we always label our axis. So then you just click in there and write what that is, right? And then click in here and write what that is, which is N, right? And then I personally hate these little lines. These annoy the crap out of me. So what I do with these is I just like right click on them and like, I'm like, no, thank you, go away. I made them go away because I don't like them. Yeah. So tweak it however, right? Make it look pretty, make it have everything you want it to have, right? But I did that for you already. So we don't need two of these. Okay. You are not going to include your performance curve in your lab report because it is a tool that we're using to be able to make comments on if our sample size was large enough or not. It is not the bulk of what we're trying to speak to. Okay. So what do we think about that performance curve? So it's labeled. Oh, you can't tell because it's sorry. So blue and red, they're colored. We could do a dashed line or a solid line, if you want to do that instead. But it's so in this particular case, one of them is leveling off a little better than the other. Which ones are more consistent? The top line. So that's our interior, right? And then the exterior is the bottom line, which is a little wonky. So what do we think about our sample size? Just kind of looking at both of them together, right? So not differentiating between the two, but just looking at them collectively. What do we think about our sample size? It feels pretty reasonable here, right? Like right around here or so, it's not wiggling much, right? The other one is sort of problematic, right? Because it's kind of like, right? So one might say in their discussion something to the effect of, while the performance curve indicates that the interior lines or that the interior leaves, the sample size was large enough, there appears to be more variation in the exterior leaves, for example, something like that, right? So we're not including this in our lab report. This is just a tool to help us. Yeah? Yes. Something that you can comment on. Okay. Now, the other thing that I've given you, because I'm a nice person, is, ooh, what's all this business down here? One of the things I want you to report in this lab report and some of the other ones is just like general stats for your data. Okay. So it's still on this interior, exterior leaf length thing. But what we have here is this is little titles that I put in. But once again, when I click on the cell, notice that it includes the equation, right? So what is in this little box is the minimum. So what does that mean? That's the smallest value in cells B3 through B112. And then this one is what is the smallest value in C3 through C112, right? Max value in the same data set, max value in the same data set. Range, what does range do? Range, they don't have an equation for range. So what I did is I just said, well, range is the max minus the min. So I just typed in equals to this cell minus that cell to give us our range. Yeah. Okay, cool. Oh, there's our average again. So that should be, oh, wait. That should be the same. Why is that different from this? Oh, no. It should be different. Oh, wait. This should be the same as this. I was looking at the wrong column, right? So that's our mean for the whole data set. This is our mean for this whole data set. And then the median, hey, what does median do again? It's the middle number. Yeah. Okay. So slightly different from the mean in both cases. Yes. That's interesting. Not that different, but a little bit different. That's kind of interesting. And then what's mode? It's the number that appears most often. Okay. Now, particularly in smaller data sets, it is very common for there to be no mode. If each of your numbers is different, there is no mode. A mode doesn't exist. What happens when there's no mode? It says, I believe it says hashtag NA, as in this is not applicable. Yeah. So when you see that in your, your data, right? Because you're going to do basically this stuff for just your tree. That's what this page is about. Okay. So you're going to do this for just your tree. Just your data, right? Just your leaves, right? And so if it says hashtag NA, that means it does not apply for these data. Okay. The other ones, these are all weird error messages because there's nothing in these cells yet, right? Okay. And then we have variance and standard deviation. What do variance and standard deviation do again? Remind me. They are similar numbers that measure, huh?
Or they are.
So the spread from the mean, right? So are the data points like scattered way far away from the mean, or are they real tight in the middle of the mean? And just looking at this without thinking about it real hard, this number compared to this number is not surprising to me, right? Because remember our performance curve? Remember how this got settled down real tight to just a straight line real fast? Because these data on the interior have less deviation, right? They're closer to the mean, whereas these ones are 50% higher in their deviation, right? So it goes from 0.9 to 1.5, which means that those numbers are kind of all over the place more. There's more variation with those. Yeah. And you could, propose a potential hypothesis for why that might be the case. I have some ideas. I am not going to, spout those off because I want you guys to think about it a little bit, maybe. Okay. So you're going to basically, what you're going to get from me, right, is you are going to get from me, not this, because I'm going to analyze all of our data together for my lab report. What you guys are going to do is you're going to do just yours, right? So you're not going to get this tab. You're going to get this tab, and you're going to type in, right? So make sure that you and your partner each have each other's values in here. Yeah. But all of the equations are not in there. I need to put them in there. Make sure somebody remind me to put the equations in for the performance curve, that this is here. So you're going to have to put in your own labels. I'm not going to do that for you, right? You're going to have to put in your own labels, but I will put in the, you know what? I'm going to make you do it. There's a video telling you how to do it. I'm going to make you guys do it. Forget that. Okay. So you're going to get this, and this is going to tell you what I need you to do, but you're going to be able to do it yourself. Okay. These are already in here. All right. Yeah. So you're going to put in, what are we doing for performance curve again? $, dollar, something, B, and then B, $3, because that's where we're starting. And then colon, B3, not $, because we want that one to change. Close parentheses. Yeah. And then you're going to, but in this one over here, it's going to be C. And then, oh, once I got both of them, oh, watch this. Watch this. I only have to drag once if I do it that way. Boom. Right. So I'm going to delete what I just put in there because I want to make you do it yourself. But see, that took me 30 seconds, you guys. You can do that. Okay. Now, there's also another tab here that I'm calling Pretty for Paper, because this is where you are going, where I made some things to kind of help you with your paper. Okay. So look at this. Descriptive stats, central tendency distribution around mean. So this is just a nice place where we can just kind of copy and paste this loveliness and put it in your lab report. But you're going to have to move your data over your data. You're going to have to move your data over here. How are we moving our data? It's this data that we're moving over. Actually, no, it's not, because this is your raw data. It's this that you're going to move over. How are we going to move it over there? So I highlight it. I copy it. How do I paste? Do I just hit paste? No, because then it's going to be like, we're pasting equations and now we're confused and you're going to get gobbledygook. So when you want it to just paste the numbers, you pick paste values, which has a little numbers. You see the little numbers on the thingy, right? That's a good reminder for paste values. Just go boop like that. And so right now it's that because we didn't put anything in there, but yours will have, yeah. Okay. And then here's a spot for you to make a nice little table for what your results are for your stats test, which we're going to do in a second. Okay. So this will end up being either T. So it'll be T. That's not what I wanted to do. No. Delete. This cell will have either T or U equals, nope, not plus, equals. So you'll put that in, and then I put this, oh, exclamation point. If whether or not you're accepting or rejecting your null. Okay. By the way, one of my students last semester who had taken a stats class, she was like, here's how you remember whether or not to accept or reject a null hypothesis. It was something about like the size of the P and whether or not you accept or reject the hoe. And I was like, okay, that's no. I'm not gonna, anyway, somebody can figure that, you guys can figure that out if that motivates you, but I'm not gonna go there. Okay, right. But it works. It totally worked. When she said it, I was like, that's perfect. Anyway, so I'll let you guys figure that out. So then you are gonna have a table 1. I'm not giving you table 1 because your table 1 is gonna be your raw data, right? Which is over there. So you can just copy and paste that there. Okay. And then I gave you a setup for a graph that's going to happen. Right. But the graph is going to be based on your mean leaf length. So what you got to do there is you just take your mean leaf length, you copy and paste it here. Yeah. and it'll populate the graph. Okay. The reason I made this separate is because I wanted you to be able to see that. Okay. So I'm going to do mine. Here's what I want to do. I'm going to hold on. I got to save this as mine real quick. And then I'm going to mess with it. So save as me browse because I want it to be there. And this is fall. So I'm saving my work because I'm going to use that later. Okay. Who calling me? No, thank you. Okay. So then what we're going to do, raw data. You don't get this tab. But since I'm doing mine, right? What I'm going to do is I'm going to take this. I'm going to copy. I'm going to paste. And then I'm going to copy. I'm going to paste. Yeah. And then I'm going to copy. I'm going to paste. Look at how beautiful that is. Okay. So mean leaf length in oak trees. It already did our interior versus exterior for us. And it did our mean is the bar, right? What is the deal with the whiskers? That is the hardest thing to get Excel to do. And so what you have to do, so I'll show you how I did those. What you have to do for those is you have to go to format error bars. And if you just tell it, notice over here it says standard deviation, you might be thinking to yourself, cool, I'll just have it calculate the standard deviation. But if you do that, it's going to be dumb. It's going to do something weird that I don't understand. So to get around the something weird that I don't understand, what we do is we do custom. We click on custom. And then for specify value, what we do is we highlight. See how this is highlighted? We highlight what we know the standard deviation is, and we copy it and paste it into positive error value and negative error value. And then we hit OK. And it does our whiskers the right way. So you know how to do it now, even though you're not going to have to do that because it's going to come up on its own anyway. Okay. So that's your graph. So the last thing we have to talk about as far as like what you need to make using Excel, we have to do our testing. Yes. So let's go to StatKitty. All right. So what's the first thing that we need to do in StatCat? I'll go make it big for a minute. What's the first thing we need to do? Oh, thank you. We got to test for normality, right? Because we have to, in order to decide if we're doing a parametric test or non-parametric test, we have to do that, right? So let's go back to here, back to my raw data. And so I'm going to do interior and exterior separate just to make my life easier. So once again, I'm just copying that whole column. So copy, and then open up StatKitty and start at the one, just paste that in there. Boom. Okay. And then it tells you right here, we don't need to pay any attention to any of this crap, right? What does it say? Distribution is normal. Okay. So we know that what was that? Interior or exterior? I can't even remember what we did. Squirrel. That was our interior. So we know interior is normal distributed for the whole class. It might not be for your tree. Okay. So you're going to have to make that determination. Okay. And then highlight, 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 copy, StatKitty, paste. Distribution is normal. Woo-hoo! That means I can use the parametric test. Okay. So for me, right, for my data for the whole class, I'm going to go over here and I'm going to be like, well, for me, that means I'm going to pick which test, Man, Whitney, U, or t-test. Which one am I going to pick? And of course, I picked the one that you can't read. Hold on, hold on. Let me open this up again. Do I just have one that's plain? No. Okay, which one am I picking? So for me, it was parametric. So which way do I go? So I pick parametric. Is it, and we're comparing a sample to a sample? How many comparisons are we doing? One. Paired versus non-paired means, were you looking at measurements where the numbers go together? And ours don't, because you were looking at one leaf was your sun leaf, one leaf was your shade leaf, and they were not the same leaves, right? If you were looking at something where the data like were, you know, tied to each other somehow, that would be paired. So this is non-paired. So then we're doing I'm doing an unpaired t-test. Yes? Okay. What would you do if you were doing if you had to do a non-parametric test? It's still one comparison, right? And it's and it's not paired. So what you're going to do is a U-test, okay? And what we call the U-test in StatKitty is we call it the Mann-Whitney U, but both of them are in two sample independent. And this says this in the PowerPoint if you need a reminder. It says where to find it. You know, in the PowerPoint, it talks about it. Okay. So this has all the results you could possibly need, whether you're parametric or non-parametric. Okay. So now I'm going to grab my data one more time because I want both columns. Right. So now instead of doing my two columns separate, I'm getting both columns. And I'm copying that bad boy, copy, and then I'll go paste it into StatKitty. And remember, I'm going to paste it as a number, paste it special. Oh, man, and there's all kinds of crap to look at, which is overwhelming. But we're going to take it step by step, okay? So the first step is, if you are using the non-parametric test, here's your U value. Here's your P's. Which P are we picking? Which P should we be reporting? The one-tailed or the two-tailed? This is a one-tailed hypothesis, right? We are expecting one of them to be longer than the other one, but not the other way around. So regardless of whether or not you're parametric or non-parametric, we're all doing one-tailed. So you can ignore the two-tailed P. Okay, now, what is this about? It says 5.2 E minus 0.6. What does that mean? That's the lame scientific notation that Excel does. So is that below 0.05? Sure is. Way below. Excellent. Okay, so you report if you're doing the Mann-Whitney U, you report U and you report your one-tailed P. Okay? Because I am doing, right? I'm not doing Mann-Whitney U. I'm doing a t-test. So what I'm going to report is I'm going to report T1. Oh, wait, no. I'm going to report T, right? And I'm going to report P, also one-tailed though. Yeah. Right. So I'm going to put in my T and my P and then whether or not I accept or reject. Okay. So let's go back. So if you're doing a U, congratulations, your life is easier. Why don't we just everybody do a U? Why do we care? Again, remind me. It has to do with being parametric. Parametric tests are less susceptible to error, therefore better. So if you can do a parametric test, you should. If you can't, you just can't. So we do a U instead. Okay, so the U is not as good. But if that's what you got, that's what you got. Okay, but since I can do a T, I'm going to do a T. Gonna do a T. So this is gonna be the most unhinged video ever. When I go back and look at this, I'm gonna be like, what is happening right now? Okay, so we got to go back to that PowerPoint because I can't even remember what's on it, and I do this every freaking semester. So where were we? So you're using the two sample independent tab in StatCat. Yes, you enter your two data sets. You need to figure out what to report. So the first thing, if you're using U, you just do U. If your data is not, then we do the test for homoskedasticity. Right? Well, here's my test for homoskedasticity. I'm going to scoot this over just no, I'm not. I'm going to leave it right there. What does it say for my test for homoskedasticity? What does it say for both of my p-values? Are they above or below 0.05? Below. So that means, according to this, that I have equal variances. Oh, wait, that they're unequal. Sorry. They are unequal. No, they're not equal. Yeah, because it's below 0.05. So then I have to pick this row here because I have unequal variances. You're probably going to have unequal variances too. I'm just saying. Because remember when we did this? Remember how different our variances were? So I suspect you're going to have unequal variances too, just based on that. But let StatCat tell you what it thinks. Okay. So I got the unequal variances. So this is my T value that I'm going to report. I'm also going to report my D at my degrees of freedom because why the hell not? And then which P am I reporting? The one-tailed. So holy shnikes. That is a low P. So I'm going to type that in scientific notation. I'm not going to put all those zeros in that table because that's dumb. Right? So I'm going to be writing in 3.3 times 10 to the negative 14 is my p-value. So what is the conclusion that I can make from that based on the entire class data? We can reject the null with impunity. Right? Because that P is low. So yeah, this happened. This is what's happening. I feel confident about that. Right? I'm still not going to use the word prove, proven, blah, blah, blah. But based on our study, based on our sample size, based on everything else for all of our data, I feel pretty comfortable with this. Yours might not, because you might have to use the non-parametric test. Your sample size is a lot smaller because it's only 10 of each, right? And so your p-value, I don't even know what's going to happen because it's going to depend on your lease, right? But yeah.
So why couldn't I just tell that from our data?
Why couldn't we just tell that with our data? That's actually a really good question. I'm super glad you asked that. It's a good question. Why can't we just tell just by looking at the numbers? How do you know how different is different enough? That's what statistics do for us, right? What statistical analysis does is it tells us, are these differences different enough? Or is it just based on error, right? Is it just based on like slight variation that's not meaningful, right? So in an example like this, where you can clearly see when you're typing them in, right, that there's a difference, in that case, it's kind of like, why did we bother with doing all the stats, right? Well, the reason that we always bother, right, is because doing a statistical analysis is a way of saying, of confirming what we think we see by actually testing it, right? So that's why. Does that make sense? Okay. So even though that's the impression you have, and you probably already know like how this is going to work out, right? That's the impression you have because in this case, the data is really clear, just the raw data, right? But we do the analysis anyway to prove it to ourselves. Yeah. To have evidence for why that's true. Yes. Okay. So you know where the things are in the things. Okay. So the last thing I'm going to show you before I stop this video is all right. I should have been doing this earlier and I did not. So I'm going to have to do this right after class and then give it to you guys. So I'm going to show you one from last. I'm going to show you the one from last. Shit, not that. Sorry. Ooh, language on the recording, Sarah. Jeez. It's very professional up in here. Okay. Where is my, this one? Need more. Here we go. Okay. Hey, look at me. Look at this. Look at this. I'm giving you a half completed lab report, and you're just going to fill in the blanks. Okay. So what did we do? Oh, comparison of interior and exterior leaves of the canopy of live oak trees. Look at that. How fancy are we? Right? And it's not spring. It's fall. So I'm going to change that. Right? And what's the date today? Okay, so 6 September. Okay, now, I wrote an introduction for us. Is it good? Let's see. Live oaks are well suited to living in Southern California with its dry, hot summers and cool, wet winters. According to Smith and Smith. Oh, look, I'm referring to somebody who wrote something. So you best believe they're going to be listed in my lit cited section, right? Okay. So I did the reading for you. According to them, in the northern hemisphere, leaves on the north-facing side of trees have less exposure to solar radiation than leaves on the south-facing side. Wait a minute. Does that even apply to us? Did we do anything about north versus south? No. So I need to change this because that's not the question we were asking, right? Okay, so I'm going to delete that. So I also happen to remember that they said leaves, according to Smith and Smith, leaves with greater sun exposure tend to have less surface area than leaves with lower sun exposure. Okay, is that even what I mean? According to Smith and Smith. That's not what I meant to say there. What did I say there before? What did it say? Okay, hold please. This is me workshopping my own writing. I'm going to copy that and then I'm going to go back to what did I... This is not according to Smith and Smith. Okay, I'm fixing. Oh, wait. Crap, I went back too far. What day is it? Okay, fixed. Fix that. Okay. Okay, I'm gonna do this. I'm gonna tweak it, right? So leaves on the exposed surfaces of trees have outer. No. Yeah, hold please. On the exterior surfaces of trees have more exposure to solar radiation. And leaves on the interior, which have... Okay, hold on. Did I fix my sentence right? Leaves on the exterior surfaces of trees have more exposure to solar radiation than leaves on the interior, which have less exposure to solar radiation. According to Smith and Smith, leaves on the exterior can't spell exterior. Of a tree would experience more heat stress and more water loss. Okay, I need to fix this. I'm just going to make myself a note to fix this real quick. I'll fix it. Okay, so then I got my background, right? And then I got this is what we did. And here's our hypothesis. It is predicted that leaves from the more heavily shaded interior of the tree will be longer because they need more surface area to perform photosynthesis, right? Or they are less heat stressed. Would work too. Whatever. Okay. Leaves were collected. I got to update this. That's a note to myself to update that. Notice that I said where the leaves were collected. Yes. Trees were located east of the Delore lab on a slope next to a parking lot. You're going to put your own GPS coordinates there for whichever tree you collected your leaves from. Yes. Each group of investigators haphazardly roughly the same compass direction. We didn't even do that. So we didn't do haphazard. We didn't do... Anyway, I'm running out of time, so I got to shut up. Okay. Lisa, oh, we did not do this either. Oh. Delete. Length was measured using Vernier calipers to the nearest 0.01. Yeah. StatCat, blah, 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 blah. Okay. So I did this for you, right? I'm going to post that. So then what I'm telling you here is I basically have given you your results, the text for your results. Table 1 lists the raw data to tell you what to put in there. So table 1 lists the raw data for leaves measured by a pair of students. So you and your partner, or the three of you, whatever. You don't need to list your names because we are decentralizing you. It don't matter. Tables 2 and 3 include various statistics performed. You're going to include those two tables, right? You know where those are. Those are on that Excel file. And then you're going to include figure 1, which is your bar graph. Dun, 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 dun. Boom. Okay. So what you're going to do is you're going to make those 3 tables and 1 figure, and you're going to copy and paste them right there in this Word document. So you don't need to write anything in results. You just need to plop those there. So the red is the stuff you need to do. Okay. And then you're going to write your own discussion. Okay. Do you know what your assignment is? Okay. I am going to stop recording now. Wait, hold on. Hold on. Stop. How do I do this? Go ahead. Talk. Okay, hold on. I don't know how to stop recording, you guys, without making it big. Do I? I'm going to stop sharing. That's what I'm going to do. And then I'm going to stop recording.
Stop right there.
Yes, I want